In this week's deep dive, we're going to take a deeper look at the integumentary system, or what most people would refer to as the skin, although as we're about to see, there's more than just the skin here. Now, this is part of the integumentary system at the upper to mid-back level of one of our cadavers. Now, there are three main layers that we're going to be focusing on today, and the most superficial layer, and the one that we're all familiar with because we see it every day, is going to be the epidermis. Now, if you actually break that term down, epi means on top of or upon, and dermis is actually in reference to the skin, or the next layer down. And if I turn this to the side, and I'll pull this up to the camera, hopefully you'll be able to see this, you should notice a paper-thin layer on top of a thicker layer below it. Maybe if I turn it around, we might even be able to see it better from this side. But that paper-thin layer on top is the epidermis. Now, it's about 50 to 100 cell layers thick, unless you have a callus. If you're calloused, then that layer can actually get thicker. And it's just going to rest again on top of the dermis. Now, the dermis is where all the really exciting stuff of the skin happens. This is where you're going to find sweat glands, nerve endings, blood vessels. In fact, if I actually flip this over, you can see this area right here is going to be the dermis, and then all that yellow is going to be the next layer down called the hypodermis, or the subcutaneous tissue, the telosubcutaneous. There's so many names for the fatty layer, it actually can be very frustrating to teach. But as you see here, you're going to see like blood vessels in throughout. Now that's the interesting part, is that the epidermis itself is avascular. There's no blood in your epidermis. And that's on purpose, because if you were to get just even bumped on the arm or something like that, what that could do if you had blood vessels is rupture them, and then you could bleed very easily. The purpose of your epidermis is actually to protect you from friction and abrasion or scrapes. So it's also going to flake off. And it takes around a month or so from cells to go from the basal layer and divide up and then flake off into the air to create household dust, among other things. But the dermis itself is going to be filled, actually let's look at it from this view, like I said, with blood vessels, but also lots and lots of collagen, and that's going to make it very tough. This is where the toughness of the skin comes from. So the epidermis helps to protect it from friction, while the dermis is really tough and helps just give padding as well as support for all the structures that are going to be inside of there. Like I said, sweat glands, such as like the eccrine or sudoriferous gland, which is going to be that watery sweat that leaks out onto the surface of the skin, as well as apocrine glands. Apocrine glands are the ones that they become fully activated when you hit puberty, and they start secreting like this milky, almost sweat that is very odorous. This is what we call body odor. It's going to be, those glands are going to be located in your pits and your genitals and those types of areas. So the dermis is just going to be very, very fibrous. Now, below it though, like I said, is going to be the hypodermis, and that's all this fatty tissue here, all the yellow. And fat is actually really important. I know that seems kind of counterintuitive to a lot of you because we're doing everything we can to get rid of adipose, but adipose tissue is actually a good energy storage. So there are all these cells in here that are basically just filled with lipids, an oil that is meant as an energy storage. So when you have excess calories, it'll go here and it gets stored there for a rainy day, you could think of. And this is actually really important because our ability to gain weight this way, evolutionary biologists believe, as one of the biggest contributors to brain growth. In the fact that, say you stumble upon a berry patch, this is tens and hundreds of thousands of years ago, you can hoard all those calories, turn it into fat, and now you don't have to be constantly eating, and then those excess calories can actually go to the brain and help fuel its growth. So having fatty tissue has actually been highly beneficial for our species. Now, obviously, you can have too much adipose tissue, and what will happen is the cells will just swell up and get bigger, and so you're going to get a thicker layer of that subcutaneous tissue, and that's what we just commonly refer to as fat. But it is an extremely important type of tissue that's also going to help insulate, it's going to help do padding, and just keep further separation, I should say, between the outside world and the underlying connective tissue. So underneath the adipose tissue, that's where you would find connective tissue like fascia. Fascia is a bunch of collagen that's going to wrap on the outside of muscles. But this is one of the thickest areas of skin in the human body. It's not always this thick. And in fact, I have, as a real quick example, some other areas for us to quickly look at. So I'm actually going to unfold this, and as I do, I have some other skin inside of here. Now, I don't know how well this is going to come across on the camera, but I'll do my best. this is actually going to be skin from an eyelid. And then over here, I have skin from a cheek. Now, the eyelid is actually going to be a lot thinner than the cheek, but the cheek skin is still going to be very thin itself. And then we also have skin from a lower leg, so around the calf region. Now, the thing to understand is all of these have an epidermis, dermis, and hypodermis. The only difference is in thickness. And a lot of that difference in thickness has to do with how much movement is happening underneath. I mean, can you imagine if the eyelids, if I can pull this out, if the eyelids were really thick, like, say, the back skin? I mean, blinking would be highly impractical. And then also, interestingly, the eyelids don't have many adipose cells, meaning that you don't gain a lot of weight in the eyelids, which again is pretty cool, because can you imagine if you had too many Pop-Tarts and all of a sudden, your eyes are just sealed shut because you gained weight there. So you're going to see the difference in skin thickness, a lot of it based on movement. You need thinner skin when there's a lot of movement, such as with the face, right? There's a lot of movement happening in the face, so it makes sense that you'd want to have thinner skin for that. But there's not a ton of movement on the back. I mean, sure, you have trapezius, latissimus dorsi, and a few other muscles, but it's not a ton of movement, so it makes sense for that to be thicker. All right, so I hope you enjoyed this week's deep dive on the integumentary system, and I will see you next week.